Okay, so we are writing some tests for Rust today. Sorry, I am not streaming a lot because I'm quite busy. I also next week I'm also going abroad for events, so I will be going to PyCon Poland. So yeah, I would have some gap of streaming. I need to take a break or something like that. But I would, yeah, when I have time, I would just come back here and learn some Rust and stream to kind of motivate myself to learn to keep on learning and not give up because it's this thing is actually quite hard. It's very different. There's all this lifetime and stuff that it could be tricky. But we are writing tests today, so test is quite important. Also, I'm thinking about maybe we can also do some wrestling exercise, which I have no idea. I haven't tried that before. But just to change things up a little bit. But we'll finish reading chapter 11 first, because I think writing testing is quite important. So let's finish this chapter and then we would think about what to do next. So, writing automated test. It's the Humble Programmer book. Oh, I think that book is very famous. But yeah, I haven't read that. Program testing can be a very effective way to show the presence of bug, of course. Inadequate for showing their absence. Yeah. So we can't just write code without the test. That's what basically is. You can't just rely on, oh, I'm trying it a few times and it's good, then it's good to go. No, we can't. We have to have automated tests. So Rust is going to have something there to help us out. So write a function add two to whatever number, accept an integer and return an integer, implement and compile that function. A string value for an invalid reference. Yeah, so for string it's quite tricky. Right, test that. So for example, when we pass 3 to add to function, the return value is 5. We can run these tests whenever we make changes to our code. Testing is a complex skills. Yeah. But I think testing skills can be quite transferable. It's just that when there's a new language, there will be new tools, new mechanics and stuff, but the principles are the same. I hope. So let's move on to read a little bit further. Non-test code is functioning in this expected manner. The body of test function will have these 3 actions: set up any need data or status. So basically, I always think of testing like cooking, right? You have to get all the ingredients ready, chop them up and stuff, and then run the code to test that you put all of them into, let's say you're stir frying, you put them in the wok. So that's how you run the code and assert the result, and at the end you just eat it to see if it's okay, right? So yeah, that's the 3 step. Let's look at the feature Rust provide specifically for writing tests. That will take these actions, which include the test attribute, some macros, and should panic attribute. That's something like PyTest also give us that raises that to check whether it's raise an exception in Python. But yeah, so we can also check whether something should give an error as expected. So the anatomy of a test function. So we see how it looks like. Annotate with the test attribute, where metadata about the pieces of Rust code is derived attribute that we use with a struct. That square bracket exclamation mark, whatever the thing is. Okay, so to make it into a test function, we use hash square bracket test on the line before fung. Then you run your test with cargo test. Rust built a test runner binary that run the annotated function and report on whether each test function is pass or fail. So whenever we make a new library project with Cargo, a test module with a test function is in, it is automatically generated for us. So if I think we have seen that before, no? So if we look at some of the things we had in the past, we should have, not, maybe not this one. Okay. I'm too, like, a lot of steps ahead, so maybe not that. Okay. Yeah, test modules give you a template for writing tests. You don't have to look up the exact structure and syntax every time. Some aspect of how tests work. So we will write some real-world tests that cause some code that we have written and assert its behavior is correct. Create a new library project called Adder. So I guess it needs to be a library project, which I don't know which one is the library project that we created. I totally forgot. Not the guessing game, not the Christmas. Comedy department is not a library. So maybe it's only in the. Is it a rectangle? Target? No. No, I don't think so. Okay, never mind. Let's create a new one and then we will see. So we create a library project that is called Adder. Let's clean this up a little bit. Okay. So let's go back up first, and then now we have Adder package. So let's see this. Oh yeah, we have the test here. So yeah, this is how it looks like. So for example, we have add, then yeah, I think we have seen this before, but I just forgot where it is. It's fine. So this is how the test function look like. You have like test here. I don't know why it's CFG, or does that mean more test? You super. So this is the test. So this is test config must be. But this is very simple. It doesn't tell us much. But this is the test function. It works. Test if it works, and result is using add, and then it should be 2 plus 2 should be 4, right? So this is what it is. And oh yeah, this is a little bit different as well. It doesn't have the use super thing. It must be the Rust version kind of thing. That's what's going on. That is quite different. So now let's ignore the 2 line and focus on the function. So yeah, we top 2 line, those are the probably the setting or whatever that we haven't learned it yet. Look at the test annotation. This attribute indicates that this is a test function, and then yeah, we also have a non-test function in the test module actually. So we can write other functions that may be like helper function and things like that, but then they should not have this test thingy. Uses the test assert equal macro to assert if the things are equal. So this is like assert in Python, but that is a keyword, but in Rust we use a macro to do that. 2 plus 2 equals to 4. Assertions serve as an example of the format for a typical test. So let's test it out. So okay, where's my okay, so cargo test. Oh, I'm in the wrong directory, sorry about that. Let's do that again, and then we're running the test, and running one test. It works. Okay, so yep, compile and run the test. We see that running one test. Next line show the name of the generated test result called it works, and then the result is okay. So that's it's okay. 1 passes and 0 fails. Possible to mark a test as ignore. Oh, we already mark skip. So we ignore a test. So don't run a particular in a particular instance. We'll cover that later. Yeah, so PyTest also have that. I've given a talk about that. Like PyTest, you can skip tests or mark a test as non fail. So yeah, so but in Rust you can do that obviously, but they are teaching you, which is a good thing. Is Yeah, I love it. Because we haven't done that here, somebody show zero ignored, and then we pass an argument to a cargo test command. So also we haven't filtered the test result. So when we run the command line, run the cargo test, we can also filter which specific test to run. For example, if we have a lot of tests, if we are just like fixing one thing, then you just want to fix that first, and then you just want to run one test until everything is fine, and then you may want to run it again with everything. Then to make the development faster, you can just filter out the relevant test to test. So but we haven't done that, so it's not there. So it's zero filtered out. Zero measured statistic is for benchmark that measure performance. Benchmark tests are, as of this writing, only available in the nightly Rust. Ooh, so we are not going to cover that, I guess. But it will be fine. It will be great to have a performance measure kind of thing standardized. I love that. On the next part of the test output string is there's an auto doc test. Ooh, it's for result of any documentation tests. We don't have any documentation test yet, but Rust can compile any code example. And doc test is also also there. Everything that we know and love is already exists in Rust. Yeah. So yeah, I think like the good thing is like Cargo is basically like a one-stop like Rust program development toolkit kind of thing. It got a lot of things that's very useful. This feature help you have your doc and your code in sync. Yes, doc test is quite important, but not a lot of people run doc tests on Python actually. Python you have to use a specific library to do that. Let's start to, or maybe yeah, but like I just didn't see too much of them. So yeah. Start to customize the test to our own need. Let's change the name of it works function to different name. Exploration. Okay. Just following steps now. So change it. And then so now it will change the name. Yeah, so you see that we have no filtered out and the zero measure and then doc test. Yeah, there's no test. So if we test now, we would have the name instead of it works is exploration. And then we are now adding another test, so we add another. Oh, I'll just copy here. Ooh, we have a little crap there, so we know that this thing will have a problem. So let's just put like that, and then panic, make this test fail. Oh, because we want this to fail. So this one will panic because there's a panic, right? So let's test. Yeah, it will fail. The test, another is failing. So because it's panicked, so it doesn't work. Run the test again, and then yeah, we see that it fails. Two new section appears, and now we should of course have the reason for the failure, and then yeah, the reason for each test failure. Get details because it failed because we panicked on the line 10. The next section lists the name of all the failed tests, so you can go and hunt them down one by one. We can use the name of the failing test to run just tests. Ooh, more easily debug it. Yeah, sometimes again, like if you have a lot of tests, you may want to only care about the one those failed. So yeah, so then we can like, oh, maybe I want to fix another, so you can like just run that. Yeah, we'll so there's also this like control how test the run session here. Yeah, for example, do you want to run it on one thread and things, show output. I think this is a good place to refer back to when we further down the line, because ignore, so we just have a quick look. So yeah, we can ignore by putting ignore, or we can use dash ignore. Yeah, okay. Come back. Seeing what the test result looks in different scenario, look at some macro that other than panic that are useful in tests. The assert macro provided by the standard library is useful when you want to ensure some condition in test evaluated true. Giving assert macro an argument that evaluates to a boolean. If the result is true, nothing happens and the test passes. If the result is false, the assert macro will call the panic and make it fail. Using the assert macro helps us check that our code is functioning in the way that we intended. So we have the rectangle struct and a can hold method, which are repeated here. Put this code in a file, then write some tests using the assert macro. So this is the code that we had before, and then we can put it instead of pub, maybe put it here. I'll just keep the add for now, and then we have the rectangle struct, and then remember we have the can hold, which is like a method. And okay, the can hold method will return a boolean, which means that it's perfect use case for assert. So we write the test that execute the can hold method by creating a rectangle. So now we want to write the test. So it's larger can hold smaller, so that's the test, and then we want to put it there. So let's put this test function in there. I guess I would just overwrite these. Larger can hold smaller, so larger equals to this, and then so assert larger can hold the smaller. So this is quite straightforward. Yeah, we only assert because this will return a boolean, right? So if it's true, then it passes. If it's false, but it should not be false, right? Because larger should be able to hold the smaller. So if it's false, then something's wrong. Then assert will get a false, and then it will flow in a panic. There. We have add a new 9, which is superstar. So yeah, I think that's already there from the start. So what is it about? The test module is a regular module that follows the usual visibility rule. Because test module is an inner module, we need to bring the code under the test in the outer module into the scope of the inner module. So globe here, so everything we define in the outer module is available to this test module. So these are all available inside if we use this. Your super, so super is here, right? So anything is become here. So you can just call them, otherwise you have to super : rectangle, right? So this is what it does. Guess this is standard. Because yeah, you want to test something, and obviously it's something outside. So now we can run the test, and I have a problem. Oh yeah, it never used, but it kind of passed the test. We can add another test. Smaller cannot hold bigger, so and we'll put it here. Oops. Okay. Smaller cannot hold larger. So not smaller can hold larger. Okay. Yep. So this time we expect it to be false. So we just neglect the results. So by adding the exclamation mark there. So the two of the thing pass, so 2 passes, which is good. So they both are okay. 2 tests pass. So now let's get a bug. So what are we doing here? So we place the greater sign to the lesser sign. So this is less than sign. Oh, no, like that. Yes, less than sign. So yeah, there's a problem with our code because that's intentional. It's fine. So test. Oh, we have failed. We have 1 fail. Larger can hold smaller. That is not good. But this one still pass. Smaller can larger can hold smaller. Can still pass. No, smaller cannot hold larger. Still pass. Because oh yeah. Because if we think that, right, so width, so smaller width is smaller, so this is true, and this is false, but then so true and false is false, so this is false, and we still got a pass. Okay. Because we test both, so we catch the bug actually. If we just test this one, then we won't. Test equality with assert equal and assert NE macro. Okay. A common way to verify functionality is to test for equality between the alpha. I'm kind of in the middle. Okay. Common way to verify functionality is to test for equality between the result of the code under test and the value you expect them to be. So you can use use an assert macro and using the equal operator, or you can just like before use an assert equal macro or assert NE to perform this test. So comparing 2 arguments for equality and inequality. So NE I think it means not equal. So see why the test failed. So now we put this back in. So add 2, it adds 2. So 4 and add 2 should be the same. Yes, and then introduce a bug. We passed for the argument, yep. So now we want to introduce a bug. Introduce a bug by changing this to 3. So it's not expected behavior, obviously. Oops. Yeah, I'm using the UK keyboard. That's why the pound signs show up. Oop. Okay, left is 4, right is 5. Yeah, so if we use assert here, then it will just be a so this is, we're using assert equal, so we have left and right, but if we just use the equal and so it just said that it fails, so it doesn't have that much information like before. Because now if we do that, then we see the oops. Oh, equal. Yeah, so if we do this, then we'll see the left and right. So this is easier to debug. Yeah, so this was basically what I just said. Yeah, you just have better error message if you use assert equal and assert NE not equal. Yeah. Okay, so which means the values being compared must increment. So yeah, so they should, so they have debug formatting, and also they should have the partial equal because it's equal has been used. So they should have the partial equal and debug traits. If not, then you know, we can't use the equal sign, or we can't print out the debug information. So primitive type and the standard library type will have those traits. Struct and enum that you define yourself, you better have a partial equal if you want to assert it to whether it equals to something. You also have to implement the debug traits to print. Then you can use assert equal and assert and e. These are derivable traits. Yeah, it's quite straightforward. You can just add this, derive, partial equal and debug. So add those to your struct and enum definition. Yes, chapter 5 we have seen that before, that we add this, but we're like, oh, what's this? Yeah, so we can look at derivable traits. If I struct or enum method, implement a trait with its own default implementation of the type. Yeah, so this is handy. This is almost like a standard way of doing things, to put this onto all the structs. Because when we first used the struct here, I think, yeah, and you would put it there. Yeah. Okay. You can also add a custom message to be printed when we fail. So it's an optional argument for assert equal and assert not equal macro. Any arguments specified after the requirement are passed along to the format macro. For example, you pass a format string that contains a placeholder and value to go to these places. So how can we use those? So greeting, we have this, and then we test the greeting. So result that contain Carol. So okay, so what are we doing this? The requirement for this program hasn't been agreed upon yet. We are pretty sure the hello text at the beginning of the greetings will change. We decided we don't want to have to update the tests when the requirement change. So instead of checking with exact equality to the value returned, so maybe we change hello to hola or something. Then we just want to check that it has Carol, so we can use the contained. Yeah, just assert output contain the text of the input. So introduce a bug. So let's say we forget to put name in there. So for example, this one will pass. Okay, it passed, but then if we forget to do this, just hello, then it will fail. Yeah. Result just indicated assert fail. Which line of the session, so it doesn't tell much why it failed. Let's add a custom failure message. This is a custom failure message. Greeting did not contain name. Value was this. So we want to print out what is actually returned. So so then we can look, then it's more obvious that, oh, there's no Carol in there, there's something wrong. This is why we're getting that. Then we can investigate. So example, panic, greeting did not so it will become the panic message. Greeting did not contain the name. Value was hello. So, oh, okay, that's not here. That's why. Yeah, so the point here is that anything after this first required, this is the required parameter, because we need assert only take one thing, right? See if it's true or false. So this is the true or false one, and then after that we can put in as if it is like the format, right? So we can put in this, and then all this thing that goes into the curly bracket we'll put after. Check if a panic with should panic. So, oops, sorry. So our code handle error message, error condition. So something that should panic, we should check that whether it panics as expected. So let's see our guessing game again. So guess is a struct this time. So struct should have a value there. And then, yeah, so we're going to test, like, if we create a guess that is greater than 100, yeah, then it would panic, right? So this one is checking it should panic. So it's actually give you a okay, even though, like, you know, oh, this one will introduce a panic, but because we have a should panic, and now this actually is a okay because the panic is expected. So let's introduce a bug. So for example, we forgot to check is bigger than 100, then this one should not panic, but then we would have a panic ourselves because it failed the test. So yeah, it's supposed to panic, but it didn't, so it failed the test. Look at the test function, see annotated the should panic. Yeah, so the next question is, what if I caught the wrong panic, right? What if it panicked for the reason that is not what I'm expecting? So how can I distinguish those two? Because if it panic at a place that I'm not expecting to panic, so it should be a problem, right? We should fix that instead. So how to make it more precise? Add an optional expected parameter to the should panic attribute. We'll make sure that the failure message contains the provide tests. For example, consider the modified code for guess. Now we would new function panic with different messages. So yeah, okay, so let's copy this because this one is the same message even if it's too small or too big. So we want the different message. So one is too small, one is too big. And then, so now we can add should panic and then expect what the error message to look like. For example, if it's too big, if it caught here, then it will print out the error message less than or equals to 100. Then we can check. So if we like panic something else, right, it will give a different error message, then we know that it's not the one that we're expecting. So if we run this will again pass. Oh. What have we done? Undeclared type. We have done the super, no? Oh, because we forgot the thing before. The struct, so we should keep the struct. Sorry about that. Yeah, now this time it passed. So yeah, as you can see, like it still failed if it's something else. we put in the should panic attributes expected. For example, what happen if a should panic test expects if we swap the message, then it will fail. Or we can just put something different, like yeah, it will fail because the message is different. Must be greater than or equal to 1. Yeah. So less than or equal, so it doesn't match the expected substring, so it still fails. Okay. The failure message indicate, yep. Using result T and E in test, so far all panic when they fail. But what if instead of panic we have the result? So for example, let's copy this, it works, and then yeah, so this is our 2 plus 2 thing, right? So how can I go back now? Okay, so this one, so instead the test function will return a result, and then 2 plus 2 is okay, then error 2 is 2 is so now the it works function will not panic, but instead return a result. The body of function, rather than calling assert equal Marco, will return okay when the test passes, and error with a fail message. Writing tests, so they return enable you to use the question mark operator in the body of tests, which can be convenient to write tests that should fail if any operation within them. So we can't use should panic this time. Don't use the question mark operator on the result value. Instead, use assert value is error. So let's try. If we go back to the first one, yeah, I don't quite understand what the oh, we have to go back to what it used to be. Can I do a git check out? Oh, branch yet to be born. Okay, fine. I thought they have the initial commit, but they don't. So yeah, let's go back to when we have it. It's fine. It's not that far away. Yeah, so add 2. This one is 2, and then we is it adding 2, or is it? Oh, it's the add function. Yeah, sorry. Let's keep going further back. So it was the add function. Yeah, the add function is here. So let's replace that with our thing. Like this, and then right like that. So now if we run the test, it will pass, it's okay, but so if we want to use it somewhere, we want to cache the error, we can use the if we want to use it somewhere, we can use the question mark. But if we want to can I fail that? For example, if I do this, it will still pass because there's nothing to test. So what we do is use the question mark operator in the body of tests, which can be a convenient way to write tests that should fail if any operation within them returns the error variant. Yeah, so we can't use should panic, we can, so what should we do? Is to write another test? This is weird. So it returned, but this is not the test, right? It works. And then no. I'm a bit confused here, because if I want to cache that, I have to so this one will so I use a search so it worked out result. Or maybe I just edit at the end here. What if I edit here that for example like that. This one should not give an error. I'm not sure if I can do this either. Yeah, it doesn't work that way. Non-item marker in item position. So yeah, how can I test if it's like that? I don't know. It's not very complete. Maybe the next chapter it will explain it. I don't know. You just hang there, but doesn't like tell us. Okay, yeah, it gives us an error or an okay, but then how do we use it, right? I don't quite get this. Let's move on to see if they explain a little bit better. How to run. I still don't know how this should be used. Maybe in the future we'll come up with something that we know what's going on. Yeah, it should be like something we're calling something that gives you a okay or an error, and then you can also assert if the okay is okay or error is error, right? But I don't know. I don't know what it's talking about. Sometimes it's very difficult to guess what that means. Sometimes I'm just like completely dumb. I just like, oh, is it English? But yeah. Okay, maybe I'll take a small break. I'm a bit tired. I would go on the coffee thing. Then you could also maybe drink a coffee or buy me a coffee if you want. Then we'll come back to more readings.